Alright guys, so today we're going to go over one of the most important foundational skills to succeed in high school math in Ontario. It is long division for polynomials. You're going to need this technique when graphing rational functions. You're going to need it to calculate the oblique asymptotes. And you're also going to need this when solving equations of higher than second degree functions. So for example, when you're looking for the roots of a cubic function, you're going to need this technique. So in this case, right, we have the most basic version, right? And by the most basic version, I mean, okay, I'm using a dividend to divide by divisor. And if you look at my dividend, right, 4x cubed minus 6x squared plus 5x minus 3, I have a third degree, second degree, first degree, and 0th degree, right, in decreasing order, right? It's already ordered, right? And I'm not skipping or missing any degrees, right? For example, I'm not missing a first or second degree, right? And then for my divisor, this number on the bottom, I have a linear divisor, right? So this is one of the most basic versions. So let's see how do we do this correctly. So don't do long division, right? The first thing is that you gotta put the sign down, then you gotta put your dividend on the inside, right? 4x cubed minus 6x squared plus 5x minus 3. And you put your divisor on the outside. And I've seen many people mix up the locations of these two stuff. So then remember that this number you're going to put on the top, which is your final answer, well, depending on the situation, it could be your final answer. So this number on the top is called the quotient, right? So when you're deciding which quotient to put on there, you're really trying to answer one question, right? What is the number that I need to multiply the divisor by such that I will satisfy the highest degree term, right? So in this case, I don't really care about anything after the 6x cubed or 5x, whatever. I only care about the highest degree term, right, which is 4x cubed. So, okay, so that means actually the number I can multiply by is actually 2x cubed, right, 2x squared. So because if I multiply 2x squared by 2x, I get 4x cubed, right? And if I multiply 2x squared by minus 1, right, if I multiply these two together, I get minus 2x squared, right? Remember, I don't really care about the second or first or 0th degree as long as I can satisfy the first one, right? The highest degree term. So then, of course, now you got to do the intermediate remainder, right? So 4x cubed minus 4x cubed is obviously 0, right? Negative 6x squared minus negative 2x squared. What is this, right? Let's write it out because it often confuses people. Negative 6x squared minus negative 2x squared, right? The negative and negative becomes positive, right? So this is negative 6x squared plus 2x squared, right? So this is actually negative 4x squared, right? Give you a second to let that sink in, right? It's actually negative 4x squared. So then you got to bring down the next term, which is plus 5x, right? So, okay, so now my question is, what do I need to multiply 2x minus 1 by, so that I can satisfy the highest degree term at this step, which is negative 4x squared. Of course, in this case, we have to give it negative 2x, right? So if you put a negative 2x as a quotient, then negative 2x times 2x, which is negative 4x squared, negative 2x times negative 1, right? This part right here, right, is actually positive 2x, right? Because negative and a negative cancel it out, right? So this is positive 2x. And if you do the remainder at this step, right, so the negative 4x squared, they cancel out. Then you have 5x minus positive 2x, which is positive 3x, right? Then you bring down the next term to continue going, right? Okay, great. So I have 2x minus 1. Again, I need to think about what do I multiply by so that I can satisfy the highest degree term. I can cancel that out. So, okay, so actually I need a fraction here, which is positive 3 over 2, right? Okay, so this is going to be a little bit messy. So you have 3 over 2 times 2x minus 1. So then the first term, 3 over 2 times 2x, you have 3x, right? Then 3 over 2 times negative 1, you have minus 3 over 2, right? So the 3x and 3x cancel out. So minus 3 minus negative 3 over 2, let's write it out. Minus 3 minus negative 3 over 2 is equivalent to minus 3 plus 3 over 2, and actually you are left with minus 3 over 2, right? So minus 3 over 2, this thing is your remainder, right? And this thing on the number on the top, as we said, that's your quotient. So how does that translate to the original question that we're trying to solve? Well, let's write it out step by step. Now, 4x cubed minus 6x squared plus 5x minus 3, we can rewrite that as 2x squared minus 2x plus 3 over 2 times the divisor, which is 2x minus 1, right? Remember, quotient times divisor plus the remainder, which in this case is actually a minus, right? 3 over 2 because it's a negative 3 over 2, right? Divided by 2x minus 1. So you can actually split it into two parts, right? Because because the numerator has two terms, right? The first term is actually just simplifies down to 2x squared minus 2x plus 3 over 2. Then the second part is minus 3 over 2 over 2x minus 1. And if you really dislike this fraction on a fraction, well, you can rewrite that as we just move the 2 to the bottom, which is 3 over 2 times 2x minus 1.